everybody, it's Ms. V and welcome back to another science video. Now today I am super excited because we are starting our brand new physics unit. Now, if you haven't finished our ecosystems unit, I really want to encourage you to stop right now and go back and finish up those missing assignments or that test so that when you do come to this, you are starting fresh on a new unit and you don't have to worry about juggling two subjects together. Now, in physics, I usually have students that are really excited to start this and also a few that are a little nervous, especially if math isn't your favorite subject, because there are a lot of calculations. Now, I was once in that boat as well. I was a student who was nervous about physics. However, it's actually one of my favorite units to teach now. And that's because it's all about motion. And this is something that you guys all know. You all have experience with, speeding up and slowing down, or cars and how they move. And that's exactly what we're going to be talking about. We're going to be talking about speed, or better known as velocity, acceleration, which is just slowing down or speeding up, Newton's laws, which you may have already heard about in some other science classes, inertia, friction, and force. Now, these are all words that you may have heard of from time every now and again, and we're just going to be hashing out what these actually mean and how you calculate them. So I know that this can be a little scary for some of you, but just make sure that you always ask me questions. I am here for you guys to help you in any way that I can, and I'm going to be trying to make this as concrete and easy to understand as I can, but if for some reason you're having troubles with something, please make sure you reach out and ask me, because I am more than willing to help you out. So, as we go into our new physics adventure, may the force be with us. Sorry guys, I had to do that joke. All right, so what are some things that you should recall about force? Right? You learned about force in many of your other science classes in middle school, as well as maybe a bit in grade 9. Now, force is a push or a pull between any objects that results in their interaction, right? You pushing or pulling on a door just to go into a store or into your home, that is applying force. Now, there's two different kinds. A balanced force is when an object that has force applied to it that's equal in size, but opposite in direction. So think about if you put your hands together, kind of in a prayer position, and if you push equal amounts of pressure on both of those hands, notice that they don't move. This is because you're applying equal amounts of force and in opposite directions. One hand is pushing to the right and one hand is pushing to the left. And this means that neither of your hands move. So as a result of this equal force in opposite directions, an object that is at rest is going to stay at rest, and an object in motion is going to stay in motion. Now, what happens if you push one hand a little bit more than one another? It's going to move. However, this is something that you don't see in a balanced force, like you sitting on a chair right now, right? The force of you pushing on the chair is matched by the force the chair is pushing on you. So you stay in the same spot. If one was applying more force, then you would either be floating in the air right now, or you'd be sinking into the ground. Another fun game you can do is taking a bouncy ball or a small toy and having you and a friend push on it with the same amount of force. Now, you'll know that you've done it when the car or the toy isn't moving anymore. Right? However, when one friend pushes a little bit more than the other, that means that the toy is going to move in whatever direction. So that would be an unbalanced force. This is when an unequal amount of force is pushed on an object, or they're not pushed in opposite directions. Right? If two objects, like two amounts of force, are pushing in the same direction, it's just going to push you that much faster, further. As a result of unbalanced forces, an object will change its state of rest or motion. So if something is at rest, it's likely to start moving, and objects that are moving may speed up, slow down, change direction, or even stop, depending on how much force is applied and in what direction. So here's some examples of unbalanced forces. Now we have some people up here in the corner playing tug of war. Imagine it's you and your friend, and one of you is pulling with 50 newtons, which is a measurement for force, and you are only pulling with 30 newtons. Now this unbalanced amount of forces is going to cause you to move forward, right? You're at rest right now, however, you're going to be pulled forward, and that's going to be a change in motion. And changes in motion are all caused by unbalanced forces. Same with down here. If I have a rocket ship, the thrust from those jets causes 300 newtons of force, and this is a lot more than the amount of force in our gravity that's pulling the rocket down. Since it has more force pushing it upwards, it's going to continue moving forward. Now, this can also explain flight or you moving in your car as well. Now, today what we're going to be focusing on is investigating velocity and distance and learning how we calculate these things. The first thing I want to ask you is, how do you know that you're traveling fast? Right? If you're in a car or you're in motion, what are some clues that tell you how fast you're moving? Just think about it a little bit. Maybe think about these pictures too as a helpful hint. I don't know about you guys, but when I was a kid on a road trip, I would count hydro lines to pass the time. This is, because I didn't have a phone to sit on and play with. But when I knew we were moving fast, I could count a lot of hydro lines in a short amount of time. However, when my car was moving very slowly, I could count less hydro lines in that same amount of time. And this is just going back to that idea of, distance and time. Okay. Our speedometers use two factors that scientists use as well to determine time, and that is distance, or determine speed, which is time and distance. All speed is figuring out how far you went and how long it took you to get there. Now, I do have a little hint down here that you may also see the term displacement when talking about distance, and it's important to know that they're not the exact same thing. Let me explain. Now, distance is something that we're pretty familiar with. Distance is a measure of length, right? We usually use meters, kilometers, or centimeters as our units for length. Now, if I would like to measure that, I can use centimeters, meters, or kilometers, and I can convert between these three measurements. So I know that there are 100 centimeters in a meter. So if I would like to convert that from meters to centimeters, I simply multiply by 100. And if I would like to do the opposite, I would like to convert from centimeters to meters, I divide by 100. The same thing goes for meters and kilometers. Now there are 1,000 meters in 1 kilometer. So if I have a measurement in kilometers and I want to convert it to meters, I have to multiply by 1,000. And if I have a measurement in meters, I have to divide by 1,000 in order to get kilometers. Now, we're going to be talking about conversions in a little bit in this video, but don't worry, you're going to have a handy conversion sheet that will show you how to do all of this for the unit. Now let's talk about displacement. This is a little different from distance. Displacement is the change in the position of an object from its starting point to its end point. And this is a really handy picture that tells you all about it. Now, let's just talk about this for one quick minute. This distance shows my length of my entire journey, whereas displacement only shows me the distance from my start to my finish. A good example of this is, say I wanted to go to Walmart to buy some groceries. Now, I started off at my house and I started driving towards Walmart, but then I stopped and I got some gas. And then I got back in my car and I turned around and I went to Tim Hortons. And then I went to a friend's and had some coffee. And then I eventually made it to Walmart to pick up my groceries. Now, this entire journey and the length or the distance that it took is my total distance. However, my displacement is just from my start to my endpoint, and that would be the distance from my house to Walmart. Now, the third unit that we have to always be aware of is time. Time is a measurement of the interval between events. So the amount of time between my start and my finish. Now, we usually use seconds, hours, or minutes to measure time. And you may remember that these increase by increments of 60. So there's 60 seconds in a minute, and there's 60 minutes in 1 hour. So if I wanted to convert between these, I have to remember that in order to go from seconds to minutes, you divide by 60. In order to go from minutes to seconds, you multiply by 60. And similar for minutes to hours. Once again, this is something that'll be on your conversion sheet, so do not worry about memorizing this. Now let's talk about velocity. And what is that, and how is it different from speed, the thing that I talk about every day? Now, it kind of means the same thing, however, it's slightly different. Speed does not require a direction, whereas velocity does. So velocity is the distance something travels during a specific time interval in a specific direction. Now, an example of speed is like most Manitoba highways, which have a speed limit of 100 kilometers per hour, or towns, which is usually half that, of 50 kilometers per hour, like in Steinbach. Now, a good example of a velocity is me saying that I'm traveling west on the Trans-Canada at 110 kilometers per hour. Now, this can also be written like this, 10 kilometers per hour west. See how I have a direction here? That is what tells me that I have a velocity. Now, I won't be too much of a stickler for this, however, it is an important thing to remember. So all explanations of velocity include units. You can have kilometers per hour, kilometers per minute, and meters per second. Depending on your situation, you're going to use the units that match your situation best, right? If we're talking about cars and things that move very quickly, it's probably going to be best to use kilometers per hour. However, if we're talking about, let's be honest, me running, I'm a pretty slow runner, you're probably going to talk about that in meters per second. Now, as long as the description of velocity includes units of distance over time, you can get a fairly good idea of how fast something is going, right? You can mentally picture if it took me 3 seconds to run 12 meters, you can actually think about it in your head, how long is 12 meters? And knowing that I covered it in 3 seconds, you can kind of gauge how fast I went. Now, one thing I want to really stress to you guys is that units are very important. In any equation that you have to write out for this class, you are going to be getting a mark for including your units. So please do. It is one really easy mark that you can always get even when you're unsure of the question. So make sure that you are looking at those units and making sure that you're converting them correctly as well. And I'm going to show you how to do that in a minute. However, you will also have this handy conversion chart. So say I give you a speed measured in kilometers per hour, but in order to do your calculation, you need meters per second. Well, now you know that you simply have to divide the number you are given by 3.6. Now this is going to be a chart in a little table in a Google Doc that I'm going to be adding formulas to as we go through this unit. So always check back on it and keep track of it because it's going to be important for tests and upcoming assignments. It's going to have those useful conversions on it as well as the formulas as well. It's a really good quick reference for assignments and tests so that you're not flipping through your notes every single time. So here's a little example on convergence. Say a car is traveling west on the Trans-Canada Highway at 110 kilometers per hour. What if I asked you, well, what is that in meters per second? Well, you can go back here, and you know that my answer is 110 kilometers per hour, and I'm going to divide that by 3.6 in order to know my meters per second. So let's go ahead and do that. I have 110 kilometers per hour divided by 3.6. And that is the same as me saying 30.56 meters per second. Now here's also a useful table showing you and giving you an idea of other measurements that you can do, right? The speed of light is a very big number, and sometimes just getting comfortable with using this with different measurements can help you, right? So a cheetah can run 115 kilometers per hour, or I could also say 31.94 meters per second. Now, how do I calculate velocity or speed? So we're going to be using a very handy formula of speed or velocity is equal to distance divided by time, right? How far I went divided by how long it took me to do that or get there. And I can make this a little bit shorter and easier to write as V equals D over T. That is what you can write in all of your questions because it's a little bit easier and quicker. Now, D is equal to distance, and you can write this in kilometers or meters, and sometimes centimeters. Time is measured in hours or seconds or sometimes minutes. And velocity is a combination of those two units. So it can be kilometers per hour or meters per second. These are the two most prominent or most used units for speed or velocity. So when you know the distance an object has traveled and the time that it was taken to cover that distance, you can use division to calculate the object's average speed over that period of time. So, say I give you a word problem. There's going to be quite a few word problems in this unit. The very first step is that you're going to write out the given information in the problem. What do you know? In order to do this, you're going to write the symbol and the information that it represents. So if I gave you in a word problem and I said it was going to take Ms. V 5 seconds to run across her house, then you would say time, or T, equals 5 seconds. Notice that I always put my unit here so that I can keep track of that better. Step 2, we're also going to tell people what we're trying to find. So you can put a question mark beside this symbol so that people know what you're looking for. Third step, we're going to write down the equation that we will use. This is a very important step that most people usually forget because they get so used to it, but make sure that you always put down what equation you're using. This is also another mark that a lot of students miss out on. Step 4, we're going to plug in those numbers, and then we're going to solve and write the answer. Now, another interesting thing is that we can draw our formula in this handy triangle, and this is going to make your life easier. A lot of students will write this at the top of their assignments or on a little page so that they can just keep this in the back of their minds because it is a really helpful tool. Now, say we're looking for speed. what I can do is I can actually cover up the V in my triangle with a thumb or a circle in this case, and it's going to leave me with my actual equation. Now I know that speed is equal to distance divided by time. Perfect. All right. Now I can also use it to look for my other two factors in my equation as well. Say I'm looking for time. Well, I can cover that up with my thumb, and I now know that time is equal to distance divided by speed. Perfect. Now I have another thing that I can calculate. The last one is my distance. So if I go ahead and cover up distance, I know that it's equal to speed times time. Awesome. I'm just going to go ahead and put in my short forms, right? So that you know how you can quickly write this. Awesome. Now let's try this out with some example questions. Say we're looking for velocity. So Miss V wakes up one morning with an irresistible craving for Cocoa Pops. She gets out of bed and sprints 15 meters to her kitchen in just 3 seconds. Calculate Miss V's average speed. Obviously, I really like Cocoa Pops. So here's a little drawing. Sometimes this helps you out by just drawing it out. You can get a better idea of what's going on. And I'm going to put in that distance as well. I know that I'm 15 meters away from my Cocoa Pops, and it's going to take me 3 seconds. So I can evenly space out my little tick marks. And now this even gives you a good idea of, okay, well, how much distance is there in between each tick mark? Okay, but how are we going to calculate that as our average speed? Well, let's do a little calculation. So right, our first step is we're going to write our givens from our word equation above. Now I know that my distance is equal to 15 meters, and my time, or change in time, that's all this little triangle means, is change in time, is 3 seconds. Make sure you always write your units here. Next, I'm going to do step 2, which is, what am I looking for? Well, I am looking to calculate my average speed. So you can write it as a little v. You can write av underneath if you'd like, but you don't have to. As well as a question mark, because this tells our audience what we are looking for. Our third step is to now write the equation that we are going to use. Now remember, we're looking for speed, and according to my triangle, speed is equal to distance over time. Now step 4, I'm going to plug in my numbers, which are over here. So d is equal to 15 and t is equal to 3. Perfect. And my last step is I'm going to go ahead and do that calculation. So my speed is equal to 5 meters per second. It's always important that I carry down those units and I make sure that I have the proper unit here because I do get a mark for that. So this is how you would get full marks for a question, is by including those 5 steps. Make sure that you keep everything in there so that I can see your entire thought process and that you've shown your work. All right, now let's try and do an equation to find time. So Miss V rides her scooter to work each morning. She averages a speed of 10 kilometers per hour. If work is 30 kilometers away, how long does it take to Miss V to get there? So once again, I can go ahead and draw this out if that's going to help me visualize the idea more. There's me on my trusty scooter going to work, and that total distance is 30 kilometers. And in 1 hour, I can travel 10 kilometers. So how long is it going to take me to get to that school? So my givens is I know my distance, 30 kilometers, as well as my speed, 100 kilometers per hour. But I'm looking for my time. How long is it going to take? So for this, I can now cover up t on my handy triangle, And I now know that time is equal to distance divided by speed, or velocity. So I plug in my numbers, 30 kilometers divided by 10 kilometers per hour. And in red here, I've just canceled out the units that are matching here. And all that I'm left with is hours. Perfect. So now I know that it took me 3 hours to get to school that day. Luckily, I don't actually use a scooter and I have a car. Now our last option is finding the distance. Now Miss V goes horseback riding after school, and unfortunately she scares the horse and it takes off at a speed of 55 kilometers per hour, or 15 meters per second. How many meters does a horse travel in the 5 seconds it takes Miss V to convince the horse to stop? Now, this would probably never really happen because I'm terrified of horses, but let's look at it anyways. So, say my horse starts here and it runs all the way over here, and that happened in a span of 5 seconds, right? 1, 2, 3, 4, 5. And I know that within every single second, my horse traveled 15 meters. So by drawing this out, I can actually just add up those 15s and figure out how far my horse went. However, let's also try and calculate this out. So I have my givens. I know that my horse is going 15 meters per second, and time is 5 seconds. Now remember, we want to always make sure our units match up. So this is why I'm not using kilometers per hour, because I also have seconds. That's not going to match my time. My time has to be in the same units. So that's why I'm using 15 meters per second. And we're looking for distance. So we can use my handy dandy formula, and distance is equal to speed or velocity times time. So I go ahead and plug in my numbers, and now I can calculate to get my answer, which is 75 meters. My horse would have traveled 75 meters in those 5 seconds. It'd be one scary ride. All right, so thank you for watching, everyone. And let's just go over a few things that you need to remember. You always have to make sure that your units match before you calculate your answer. Otherwise, it will be wrong. If units don't match, you have to do conversions in order for your given numbers to match up and for you to get the right answer. So this means that, if you need an answer in kilometers per hour, you have to be using your distance in kilometers and time in hours. You have to convert if I give it to you in seconds. Similarly, if you're trying to get meters per second, you always have to make sure your distance is in meters and your time is in seconds before you do that calculation. Now, on tomorrow's practice questions, the first, I believe, 8 or 9, you do not have to do conversions, but the last 3, you will have to. So please use that conversion chart to make sure that you convert your unit over, and then you can continue to calculate. If you have any questions on this, I will be posting an answer key later on so that you can see what you did wrong and learn from it. However, if you have any questions, please let me know. Have a great day, everybody.